Hello, my name is Dr. Mashud Kabir. I am the Chief Engineer of Automation in Deutsche Bahn, DB InfraGO. Welcome to my presentation. At first, the test automation, why it is necessary. We are following the SENELEC norms, definitely. SENELEC EN 50126-4688C says that the test must be repeatable and, as far as possible, automatic. Then EULYNX EUC certification 151 says that depending on the subsystem, hundreds of test cases must be executed and evaluated. In order to realize this efficiently, all architectures and the structure of the test cases are defined with automatic execution and evaluation in mind. And also the independent assessors, for example, according to the test certificate condition 11, negative test, boundary test, load performance test must be carried out, and without test automation, such a test is almost impossible to do. This is according to the paragraph 27 EIGB, German Eisenbundesamt, German Railway, and with the identification number, this one. I would like to go to the SENELEC V model. So as we are strictly following the SENELEC standards and norms, we have taken the SENELEC development, V model development as our base guideline for development activities. And here you can see that from concept level up to design and implementation level, left side, and the right side, the system integration up to decommissioning. And here at left side, when you go system architecture and apportionment of system requirements and then requirements specification here, and every requirement should be also verified. The idea of this picture is that where we are going to use our test automation, where we stay actually, and we have identified these places. For example, at place 8.0, this is our modified V model actually for our automation. Here we can see we have to use test automation, and then after the system integration, we are also using the test automation. And at the end, this is also our long-term goal, to use our solution in after the operation, maintenance, and performance. I mean, when the products are in the field, when we will be using in DB, we would also like to use our system solution, our solution, test automation solution, for automated monitoring of defects, faults, and so on. It means that our test automation is necessary according to SENELEC norm EN 50126. Now, I would like to go to our main modules. We have decided to develop our test automation platform based on the modules, different modules. We have identified until now 18 modules, and this is we call central control framework, and those are the interfaces here. And every module will be controlled centrally, and those are mainly the software modules, and we would also need the hardware parts to realize this software or to use those software. Here you can see different interfaces, API, or it can be Ethernet, USB, or electrical, and so on. And this is the basic architecture, basic interface definition of our test automation. Then we go to our test architecture. with simulation platform. This is our architecture generation 2 actually. Here you can see that central control framework. It consists of many modules like log reprocessing module, test management tool. We are using Polarion, so this is also a module. Then visualization and recognition, like with the FrameGabber or with artificial intelligence. Then we have our IT security, our cyber security part. We have standard communication interface, SCI, CC, command and control part, and design and integrated Bedien German. This is say that control part, yeah, or the GUI part for controlling the train. This is our simulation platform. Simulation platform is mainly based on vector provided canoe simulation together with its hardwares. And we have also other parts in the in this architecture. So this is onboarding, ETCS, RBC, and so on. Let's go to then our next part. So as we are actually in the middle of our development, and that's why we don't have we have not yet implemented every part. We are still implementing and developing the concepts and so on. We have actually begun this central control framework and then canoe based development, and also connectivity and storing of logs or fetching the test case from the test management tool, or storing the defects in test management tool. We are using Polarion, and here you can see the central control framework, the connectivity between the Polarion and then central control framework. Let's now go to our test automation current setup. Here you can see this is our central control framework, which is the sum of all of the modules, because our software, our development is module-based development. So the advantage of this is that if there is any problem in one module, the other modules can still will be also working. So that's why we go with the modular-based software development. And in this central control framework, we can see that it is connected with the TMT Polarion, and we are actually automating German DST and digital for digital railway, and all of this is Germany. We are following mainly now NeuPro, and of course we will be also following EULYNX, which is European based. In this case, the current setup, you can see that the central control framework is connected. It is connecting the simulation. So at first we have our canoe-based simulation, and this simulation here, left side, this is containing one set A. It means that German set A, central Einheit. It means central unit. This can be simulation or also a real set A or control unit. And on the right side, you can see the canoe-based simulation. This is the either simulation or real. Object controller. So object controller means this point machine or light signal or train detection system or Axeler German word, and then LX or Busa, or in English level crossing, yeah, and in German Eingabe, Ausgabe, IO, or English IO, input output. So those are the different subsystems which are also possible to be simulated in canoe-based platform. And here you can see at one side this is set A, and then other side with object controller. And in reality, those two sides, we have to communicate between ZA and then object controller. And in between, we have, of course, our transmission system or Übertragung system, German. And here, the crypto and the IT security, everything is here. At set A side, we have one part. This is firewall and bahnbetriebliche IP. Yeah, it means bahn functionality related IP, and we are using this as real one, or we can also use this as virtualized in firewall. Yeah, and in our current setup, we are using here actually Fortinet devices and also OHB devices from Genua. Yeah, and here you can see, and then this part is either one, we are using here LWL cable here to connect among these two components. This is crypto boxes from Fortinet and OHB we are currently using. We have actually two channels. One is blue and another is gray. Those are actually one is normal and the other one is backup channel. If anything is wrong with one channel, we can still work the other channel. And here we have also the simulated part or real part, ILBS, so integrated light and between parts. This is the control part of the train, and then ETCS. This is European train control system, and RBC or simulated or the real one, and also the SUC simulator or train simulator, and also the diagnosis part. So this is the architecture of our current test setup. Then we go to the one picture. This is the real lab setup. We have a smart setup in our Deutsche Bahn lab in Ashburn. In one computer, we can see that this is the two computers we are using actually. One is for object controller for subsystem, and another one is for set A or the central unit. And this object controller computer is connected with this box. This is the vector hardware VN box we are using with Ethernet option, and this one vector box is connected with the crypto boxes and also with the firewall. And the other one also other computer which is set A. This is connected with also vector box, and this vector box is connected with these hardwares. So this is the general setup. Basically, we are using this setup. This is completely exactly the same setup as in the real one. Yeah, we have also tested. We test with our lab. With the real Übertragung system or transmission system or IT security, and also we test also in the other labs, our supply labs like Hitachi or other suppliers. Yeah, so. I would like to show you the picture, how it looks like, our central control framework. Currently, we have implemented two parts. So one is Canoe based simulation, simulation, and another one is Polarion connections. And if we click the Canoe configuration, then it will come. There will come another option here. Here is the different subsystem. We can choose either point or light signal or some other subsystems, and then we can run. When we start running, the other window will come. This is the Canoe from Vector, and you can see we have implemented the Canoe simulation, and also we have automated all of the automatable test cases in our simulation, in our environment, in our automation. So those test cases, DB test cases, those are test cases which have been already validated, and also those have been assessed by the assessor or German Gutachter, and those are the fundamental or very essential test cases which must be tested to qualify for a subsystem to be deployed in Deutsche Bahn. Yeah, then you can see here, this is a 4-point machine. And another one, and next slide, we can see that the test is being run here. And you can see different test cases. When this is passing, we say passed, and so on. If it is failing, then it will also say here failed. So it means that the test cases are executing here, and at the end we will get one test report, which is where we are outputting all of the steps in the test steps, yeah, and we are really verifying every byte or every bit, yeah, which is verifiable, yeah. So it means that we are testing almost everything actually, yeah, with our test setup. And yeah, then so this is actually of course this is a format from Canoe we get, and it can be also exported to PDF and other versions. We are, after when we finish, then we would like to export this report to our test management tool and Polarion, so that, and also we will be creating our test defect in Polarion directly from our CCF, Central Control Framework. So how it looks like the Polarion connection with Central Control Framework, we have just begun this one. We are not yet done, but you can see we can connect with the Polarion, and then this window is coming. We can select any file to export to Polarion and so on. We have actually our goals to implement those concepts, and you can see in the we have prioritized them, and also we have our own implementation plan. So Canoe based simulation and configuration will be finishing until 2027 and so on. And this is the 5-year 6-year milestone or target from our side, yeah. Then we have categorized all of our development activities under Central Control Framework, and here you can see simulation, test management, manipulator, and then also the interfaces and integration. Yeah? The final message from our side is that test automation is not only a concept, but also a proof of concept. And test automation was already used in limited contexts in real projects like Mettingen, and also DKS. So this is Stuttgart project. Those are the real project from German National Railway, Deutsche Bahn, and we have already used our solution to this product these projects in some context. So for example, we have used our test automation solution in our Mettingen in Donauwörth for monitoring the traffic to detect any defects. This was for an endurance test or the duration test, yeah, 72 hours test. We have used our tool, Canoe based Central Control Framework solution, and also to verify the functionalities. Test automation was also used in DKS project, Stuttgart project, yeah, Stuttgart 21 project, to verify the transmission communication metrics, yeah, with simulated object controller and set A in DB lab. By using this, we can confirm that the communication between these Bedienplatz or the HMI or control unit to the object controller, this is using. We can control the point machine left or right. We can control the light signal. We can control the TDS and so on. Yeah. Then we have also used our simulation together with Thales. We have in our lab Thales components and subsystem, and we have also used them with their system, and it is also working. And we have also used our test automation tool for our in different suppliers, like that time Hitachi. It was in 2021, and also Thales Lab in Ditzingen. So we are really, our automation tool is really with the practical or real system in Deutsche Bahn, in a digital system. This is an example from Donauwörth train station, Bahnhof. It was I have taken this in 2021 when I was involved in testing in Donauwörth, and how it looks like, how the communication looks like in a real environment. Yeah, how the traffic is. Yeah, here you can see that I have monitored actually 72 hours long the communication, yeah, via our tool, our own tool. And here you can see that the traffic for a normal train station is like 150 or 170 packets per second. And here we have our individual packets per second. And this is the way. If there is any defect or any fault occurs or communication problem occurs, then we will be seeing here gap, and we can identify this immediately. Yeah, so this is the beauty of our tool. Yeah, this is the beauty of test automation tool. Yeah, and we are really interested and we are really happy to introduce such a tool. And as I have already mentioned in my previous slides, that we are using all of the technologies what is existing in the market, and we are of course including artificial intelligence, AI, or German KI. Yeah, we are using all of the latest technologies for our test platform, and I hope that we can achieve a very good train system in Germany. I hope that the complaint from all of you that German railway is very bad in catastrophic condition, we'd be able in some years we'd be able to improve this situation by using the latest technologies and digital train. That's it from my side. I'd like to thank you very much, and I am looking forward to you for the next question and answer session. Thank you. Bye bye.